So I'm gonna do an example for the element rhenium. Rhenium is located in the periodic table in the position 75. What do you need to know for orbital configuration and Lewis structure? You need to know how to do the ECN, that is the electron configuration notation, the one that we have been doing so far, and the ring structure. This, okay? What is in the red box and the ring structure. You already know how to do that. So imagine that orbital configuration is like the same topic, the same procedure, but longer because you have to do a few more steps. Okay, so how is this going to be done? In the same way, okay? Just as a reminder, the orbital S can hold 2 electrons, P can hold 6 electrons, D 10, and F 14 electrons, okay? Just keep that in mind like always. What I do is, because I don't want to forget, what I do is I put, no, not like that, wait. I put the number of electrons just to keep it there, okay? Because I don't want to forget. Okay, I'm gonna leave it there. It's very weird that we go to the to the orbital 7. It's very weird if we do that. So I'm gonna be using just 6. Remember, this number 1, 2, 3 up to 7, it's called n, and n is just quantum number. Okay. So how are we gonna be doing this? Like always, we are gonna start from the very top. Okay, from this position right here. Okay, and we're gonna start by filling the amount of electrons required. So let's begin. I will start here in the very top, as I told you before. Okay, so I will start here. I will continue the arrows, the dash line. Okay, so there I have 2 plus 2 plus 6. I have 10 electrons. I'm working like this because I just want to be a little bit organized. 1s2, 2s2, 2p6. I have the 10 electrons over there. Okay, and then I continue. 3s2, 3p6, 3s2, 4s2, sorry. So I'm gonna make it. I have already my first 20 electrons, but I need 75, which means I need to continue working with. So let's follow the dash line again. I'm following the dash line. So I have 3d10, 4p6, 5s2. Oopsie. Okay, so it is okay. Because I can no longer continue in the same line, I will move to the second line. But I will count the number of electrons that I have so far. I have 10 and 10, 20, 30, and 8, 38. So far I have 38 electrons. Okay, so I continue. I will continue. And it says, from 5s2, I continue the dash line until I go to 4d10, 5p6, 6s2. Okay, so I say 4d10, 5p6, 6s2. Okay, then I continue. I follow the dash line up to 4f14, 5d10, 3p6, okay, and 7s2. Let's see if I'm gonna use it. I don't know if I'm gonna use it. 4f14, 5d10, 6p6, and 7s2. Let's see. How many electrons are here? I have 18 electrons. Okay. Here I have 24 electrons, and here I have 8 electrons. So let's count until we got the 75. I have 38 plus 18. How much is that?
56.
56. Okay. I still need electrons to reach the 75. Plus 24. How much is this?
80.
80. Okay. So I'm gonna stop here because there I have 80 electrons, which means I'm not gonna use this one. So here I have 80, okay? But I don't need 80, I just need 75, which means that from the last one, which is 3d10, I'm not gonna be using 10, I'm gonna be subtracting the extra electrons. With 80, I have 5 more electrons, which means to the 10, I'm gonna take those extra electrons away. So it's gonna be 10 minus 5, which is 5. And then I just make sure that I have all the electrons required. Okay, so let's see, I have 38 there, and here I have 19. Can we make sure that we have the 75 electrons now? I got
Yes.
75, so it means that the electron configuration is full, is complete. Okay, now what I'm gonna do is I'm just going to write it again in a single line. Because I like it in that way. So I'm gonna copy and paste. So the field configuration is this one. You know, I'm using different colors because I'm using different paths. But if you want to use a single color, it's gonna be also okay. So this is the full configuration. Okay, you can put it in a box. And then we're going to see the amount of electrons in the outermost level. Okay. Which one is the highest level?
6.
It is 6s2. Okay, that one is the highest or the outermost level. Okay. So how many electrons I have in the outermost? I have 2 electrons. Okay. Now, what comes after is the ring structure. Because the outermost level is 6, means that I need 6 rings, okay? This is my ring number 1, number 2, number 3, 4, 5, and 6. And as you can see, the last one, I put it in a different color. And that is for a reason, okay? So I want you to leave it there with a different color for now. It's not going to be required after, but I just want you to see why it's in a different color. The ring structure represents all, you have to reflect all the electrons over there. So I'm gonna work just with a few rings, okay? And you're gonna complete the rest of the ring. I'm gonna work with the first one. In the first ring, I have 2 electrons. So I'm gonna put them there. In the second ring, I have 8 electrons. So I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, better like this. Okay. In the third ring, I have 18 electrons. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on, okay, until you complete all the rings. How many are you gonna put in the fourth ring? You have 4s2, 4p6, 4d10, and 4f14. So it is 8 plus 10, 18 plus 14,
32, Miss.
32, okay? So you put the 32 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, and the 32, I'm going to put it here, okay? And so on until you complete the 32. Then in the level 5, you have 5s2, p6, and d5. So it is 13, 13, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And in the last one is 6s2, only 2 electrons. So I'm going to put it here. So take a look. Here in the ring structure, you can visualize then that in the outer level, in the outermost level, you have the 2 electrons that we specified in this part. Only 2 electrons, there are these 2. Okay? Those are the electrons in the outermost level. Now from this comes the Lewis structure. Okay? Pay attention because this is the most difficult step. In the Lewis structure, what you need to do in the first place is writing the element symbol. And then you have to put the electrons that you have in the outermost level. There are just 2. Okay? These 2, you're going to put it there. And voila. That's the Lewis structure. I told you it was the very difficult step. But how do you go into Lewis structure? By doing all the rest of the process. Okay, even though it's a very, very easy step, you have to do a lot of work before you can make it.
Miss,
Mm,
Uh-huh.
so if there we have 4 in the last uh, circle, one
It's
point will
gonna be
be
like
up
this.
and the other down.
Exactly.
Uh, and
You can have up to 8 electrons. That's the most. 8 electrons should look like that at the most. Okay, that's the most. If you have more than 8, it means that there is a mistake.
Means, can you repeat that part because the your camera had been freezing. I can see the process.
Sorry. I was saying that for the Lewis structure, what you have to do is you need to focus only in the outer ring. Okay, in this ring, you have to see all the electrons that you have. As you can see over there, we have two rings. So, I mean, two electrons. So, you just need to put the two electrons over there. Now, a student asked me if there is an order that we have to follow to put the electrons. And actually, there is an order that you should follow. My teacher, she explained me that we should always start from the top, and then we need to continue clockwise. Okay, so if you begin in the top, clockwise is in this direction, but I don't like it. I've seen many people that do it like this, okay, clockwise, and other people that don't do it like in clockwise method. So I think that depends on the person. Now, the what matters the most is that you visualize the dots. Okay, those two dots represent the electrons in the outermost level. Because you have two dots, you have two electrons. And that is it. That's the Lewis structure. Okay, let me. Okay. Now, the other process that comes is the orbital notation. Okay. The orbital notation, believe me, is very easy. In orbital notation, what you're going to have is the same full notation that you did before, but instead of putting the electrons, okay, like that, what you're going to be putting is just number of arrows, okay? For example, I'm gonna work only with this part because I think I won't have the time to complete it all, okay? So I'm going to work only with that part. If I can make it all, I will do it. Okay, just take a look. Okay, now it's better. Okay, there's a method that says that that you have to put some boxes. Okay, so I'm gonna do it with boxes and without boxes, and you will choose the method that you prefer. You will tell me which method you prefer. Okay, so with boxes, it's gonna be one box per every quantum number. Okay, so 1s2 is this one right here. Because I have two electrons, I will represent the two electrons with arrows. Okay, but take a look. One arrow it goes to the top, it goes upward, and the other one comes downward. Now we move to the next one, that is 2s2. Again, two electrons, which means two arrows, one up, one down. Very easy, right? Now it says 2p6, which means 6 arrows. So the correct way to do it is we start always with the arrows that are going upward. Okay, 6, I have already 3, so I continue. 4, 5, 6. And they are separated. Okay. As you can see, it requires a lot of work because you have like to be drawing each little box. Okay. So it's kind of annoying, but it looks very nice. Honestly, it looks very, very nice. So you continue, okay? You continue with 3s2. You know, 2 arrows, one top, one down. You always begin with the upward direction arrow, okay? Then it comes 3p6. That is again, you draw the 3 boxes, okay? And then the arrows. 1, 2, 3, and then 4, 5, 6, like that. First the arrows that go upward, then those that come downward. And then we have 4s2. So 2 electrons, one up, one down. So I did until here, okay? Now I will do a 3D10, but I will do it with a different method. There's another method that says that instead of boxes, you can use a line, okay? And then over the line, you put the arrows, one up, one down, one up, one down, one up, one down. Actually, it's not like this because you have to start only with the upward arrows first. But I know it's complete. Okay, 1, 2, 3, 4, and 5, and then 6, 7, 8, 9, 10, and so on. Ah, you're not seeing anything. This thing stopped. It's not synchronized. I totally hate this. You're not seeing the procedure. Okay, okay, now you can see that this. Okay. So as I was telling you, when you erase it and do it again, as I was telling you, you start with the upward arrows. 1, 2, 3, 4, 5, and then you complete the 10 of them. 6, 7, 8, 9, 10. You can use either way, okay? With the boxes or with the line. It's okay. Can you mix them? Why should you be mixing the two methods? Okay, choose one and stick to it. I prefer this one because it looks more organized, but that's the only reason. This one is simpler and still is organized. So